Okay, welcome to this ANSYS tutorial. I'm going to be going over a little bit of some mesh refinement methods that I have recently found useful. Um, Depending on your situation, what I will be going over may or may not be needed. But to show you what I've got here, I've just created an example geometry in SolidWorks, and then I saved that as an IGS file, which I have found imports well into ANSYS. So I just right-clicked here on geometry, and then you can insert your geometry and browse and choose your part. And then when we open mechanical, we've got this here. So we've just got a basic member. It's just a solid couple of bars put together, and we've got this support in between. And so you may be spotting already what our problem is going to be with our boundary conditions. We've got a fixed support here at the bottom, and then we have force applied. I've just put it on this front face right here, and yeah, I'm just using the basic static or structural steel for this demonstration. So you may be able to guess already that we're going to have a pretty big stress concentration down here. We're putting this force up. So this abrupt change in geometry is going to cause a steep stress gradient in this area. So right now we've just got this going with a default mesh, which it's done an okay job of adapting to this. You can see from the model I placed some fillets around on here to just try to smooth out and make that a little more realistic and dealing with, maybe welding the parts together. We will have some kind of a rounded edge there. But even with that, we're going to be getting a really steep stress gradient here. So what you might do is, well, we've got a few different options under mesh, right? You can add a sizing method, which will allow you to choose a line or a face. And then there's just this refinement, which is pretty nice. I'll unsuppress that and we'll generate a mesh to see what that looks like. So you can see there from the selection that I had just selected this face right here. It's tried its best to adapt with the level 3 refinement. But the problem here is that I have a really steep stress gradient, and my refinement tool here only allows me to go up as high as a level 3 refinement. And I could try messing with the selection for that and see if I can get more of this area captured in that refinement. Let's just go ahead and see what kind of a gradient. Well, actually, before we do that, oh, never mind. Okay, so let's go ahead and see how that looks when we solve. We've just got this set up to do a von Mises stress. Take a second here for it to run that. Okay, so it's completed, and now you can see we're getting that stress area. So you see the change in color is happening pretty quickly, a pretty steep gradient around here. And we have a little bit of an irregular shape. It's not too bad in this case, but I guess in certain situations, if you have a bigger moment arm over which your force is acting, this might be more extreme, or maybe if the support is smaller. So I just wanted to share a method that I learned recently. So what I'm going to do is just suppress this refinement, because what I'm finding with the refinement is that actually it keeps me from being able to go any farther. I could select more geometry here to try to get more area with this fine mesh, but in that area of interest, I might want a much finer mesh than I am allowed to get there, because in order to get a finer mesh, I'm going to need to decrease the global meshing size, just because that refinement level 3 is, as far as I can tell, it's just based off of what is the surrounding mesh size, and then what, based off of that, 3 is our refinement level. It's not very descriptive. So what we can do here is we can insert from our mesh options, we go to sizing, and then here we have a couple of options. So type, element size, and if we go to our drop down here, we have some different options. So, and this is going to also depend on what we use as our selection. If I jump in here and add just this line, that will give me a refinement along that line, which it will try to adapt the area to match up with however many elements I specify along that line. However, I had some trouble with doing that, and what I found useful was, if I just cancel that for now, I can go and in this type drop down, I can go to what's called sphere of influence, so just the third option in my list here. If I select that, it's going to ask me for a sphere center, a sphere radius, and an element size. So real quick, I'm going to show how to get that to work, and I guess just discuss a little bit of why that's useful. So first, the sphere center, we're going to need something to define. So if I go to this drop down, it's going to just the global coordinate system, which is off somewhere else and isn't really relevant to this this point of high stress. So instead, I'm going to go to this coordinate systems right here. We can see that we've just got that one, the global right now. So I insert coordinate system, and then you can see right now it's already selected. I think I already had that line selected from my previous whatever I was doing. So now it's inserted a global coordinate system at that point. You can see the coordinates. You can change the orientation. For what I'm doing right here, all I'm doing is defining the center of a sphere of influence. So really, since it selected the midpoint of that line that I'm interested in, that's all I need in this case. So I'm going to go back to my sizing, and I'm going to click sphere of influence. That's the type that I already need. So I'm going to the sphere center. This time I drop down and I see, oh, I have another option now, the coordinate system that I just created. So I select that. It's now that point where it is going to be acting. I need to choose a sphere radius, and maybe I'll just try 0.5 inches, see what that gives me. Now we need to select a geometry before it starts to give us anything. So we'll go in here. I've got this selected to get me edges. So I'll click here, here. So right now, that's just selecting one or the other. If I click apply, then you can see that that sphere is showing up. So now if I click another line, this plus comes up. If I click the plus, it's now added that to my selection for the refinement. And this fillet that I've got on here is a little bit complicated, so it's going to have a bunch of line segments here. It can be a little bit tedious to go through and select, but what you'll find is that by going through and selecting these, it's extending the effects of this refinement to the areas around these lines that I'm using. And again, if I want to subtract a line that I've already selected, I could click on it and then it comes up with that minus. So just for demonstration purposes, I've just got some of these selected. Again, that getting every single one might be helpful for your situation, but just for demonstration purposes, I'll just get what I can do pretty quickly here. So now I've got 13 edges, and we'll see how problematic that is if I've got the ones that I need in here or not. But at least I've got some of this area covered where I have the high stress gradient. So now I need to define an element size, which as I'm performing a convergence study, I'm going to be seeing how far down I need to go before that, before the results of my analysis are dependent on the size of the mesh. So maybe for now I'll just put 0.1 and use that as a starting point for now. Now I'm going to clear the generated data. That gets it to start just afresh with that mesh. So let's generate the mesh now. It takes a little bit to look through it. Okay, so now we've got a refinement that is actually really nicely spread about that area. And you can see that that refinement is going up along the support, and you can keep messing with the size. You can add more. Let's go pretty far down this time just to see what we get. Let's just generate. Okay. So yeah, now you're seeing this is getting pretty extreme. I've gone down pretty far, and you can see that I've got some kind of ugly elements that are off here to the side. So if I selected these lines as well, it's going to clean that up because it expands the influence of this refinement, basically. If I include these lines that have been left out, you see kind of where the small elements are ending. So yeah, we can just mess with the selection and it will actually make it kind of just look like this sphere of influence just kind of broke everything up. That's basically what it's doing. By defining that sphere, we're saying this is an area of special interest, and we can get this area to have a high level of mesh refinement without having to worry about making these elements in the global mesh a lot smaller, because maybe that's going to take a lot of computation time that you don't really get any value out of. So you can see there it's really dense in the area where we have a steep gradient, which in some cases might get us the results that we need to converge and have a little more confidence in what our FEA is telling us. So I hope that this has been helpful to at least someone. Thanks for watching.